Hello everyone, myself Shweta Shah and we are here for the subject computer organization and architecture, and we have started unit number 10 is my multiprocessor, and in that we are going to see today the topic that are the characteristics of the multiprocessor and the interconnection for the structure. So let us start with the first thing, the characteristics. So a multiprocessor system is a interconnection of two or more CPUs with the memory and the input output equipments. Here the terms processor in the multiprocessor you can mean either another central processing unit or a input output processor. Okay, so in multiprocessor system we will have the central processors and some other supporting support processors and multiple central processing units. Okay, as we know that the microprocessor are classified as the multiple instruction stream and multiple data stream MIMO systems. And this system delivers its high performance from the fact that the computation can be processed in parallel, like one of this way, like you can do the multiple independent job that can be made to operate in the parallel way, or you can do a single job that partition the multiple tasks in parallel way. Okay, so you can do any of these things, and we will do these things in parallel processing, and that's why we are getting the higher speeds and higher speed of operation, you can say. Now let us see the interconnection structure. That interconnection structure can be classified in many ways. Like first one, we can do the time shared common bus interconnection structure. We can do the memory interconnection structure. We can do the crossbar switch interconnection structure. We can do the multi-stage switching network interconnection structure, or we can do hypercube interconnection structure. We will see each one of them in one by one. Now, if we see the time shared structure, in this, the common bus multiprocessor system that is consisting of the number of processors that are connected through a common path, that is like the single path to the memory. A time shared common bus for the five processor that I have shown here, that is having the three CPUs and two input output processors, and they are sharing via one common bus. And the only here the constraint is that only one processor can communicate with the memory or other processor at the given time. The transfer operations are conducted by the processor, that is the control of the bus at that time. Okay, so at a time only one central processing unit will communicate with the memory, whichever is having the control. Now, if we see the second interconnection structure, then we can name it as a memory interconnection structure. In that, the memory units are divided into modules that are known as the memory modules. Here, I have shown the four memory modules and four CPUs. So each and every memory modules are connected with each and every central processing unit. Okay, so here the memory unit must have the four ports to connect with the four CPUs. And these modules must have the internal control logic to determine which port will have the access to the memory at that given time. Okay, so that's why from that the which CPU will have the control for that particular memory unit will be determined. So if we see the memory access conflicts, we can resolve it by assigning the fixed priority to each memory port. Okay, so each and every port will have the same priority. And you can do another categories for the assigning priority as well. But the advantage of this multi-port memory organization is that there will be the higher transfer rate that we can achieve, because we have divided the memories into modules and you can access that modules parallelly. So the access rate or transfer rate will be higher. And if we see the disadvantage, then this disadvantage is that it requires the expensive memory control logic and the large number of cables and interconnections. So your system will be bulky and somewhat you can say complex. Um, Next method you can use is the crossbar switch interconnection structure. In that, we will have the crossbar switches that are connected between these memory modules and the CPU. The small square here represent the cross point, which is the switch that determines the path for the processor to the memory modules. So whichever switch is crossed, that particular path will be connected. Each switch point has the control logic to set up the transfer path between the processor and the memory, and it examines the address that it is placed into the bus to determine whether this particular module is being addressed or not. It also resolves the multiple request issue for the access to the same memory module on the predetermined priority basis. So if we use the predetermined priority basis, then there will be the complexity that can be a multiple requests at the same time. But that problem we can solve with this crossbar connections. Um, Next, we can have the multi-stage switching network interconnection. In that, we are using the switches. The basic component for this is two input, two on interchange switch. These are like this. You can use this kind of switch. Here you can see this A is connected to 0, here A is connected to 1, here B is connected to 0, and here B is connected to 1. Okay, so by this way, any of the input can connect it to any of the output. Here, using this 2 cross 2 switch building block, we can determine the larger networks, larger trees as well for the source and destinations like this way. So here we have used the multiple 2 cross 2 switches, and by using this, we can create the tree, and for that we have the 4 output connections. Okay, so this way we can use the different interconnection structures for the multi-processor system. So here we are ending today's session. If you have any query, then you can contact